Okay, I'd like you to look at this problem, finding a minimum area. I think we've done enough different types of problems that you might be able to work this one out. This one's also in your textbook, so you can take a look at your textbook for a glimpse at what they're going to do. If you absolutely don't want to watch the video, you want to try it on your own and maybe see if you can understand from reading an example. I don't think that that would be a bad idea. I think that would be a great idea. But I'm also going to go over the problem right now too. So I would encourage you to give this a try, most especially since they're giving you some information here. They're giving you an area equation already for you to use. You don't really have to come up with that from scratch, although you should be able to. So what I'm going to do is I'm going to explain to you how they got this. We know that area of a rectangle is length times width. We want to find the minimum area. And the minimum area that we want to find is, let's read the problem and see. Do we want the whole picture? Do we want with the margins, without the margins? A rectangular page will contain 24 square inches of print. So the print is going to be this part right here. So that means that x times y is equal to 24. We need to see if that's what we're going to be maximizing or minimizing, or if something else is. Now the margins at the top of the page and the bottom of the page are 1.5 inches wide. So 1.5 inches wide means that I lose 1.5 inches right here and 1.5 inches right here. So that dimension, this entire dimension here, is going to be x plus 1.5 plus another 1.5. That's going to be x plus 3. Okay? Then we've got the margins on the side. So the margins on the side are 1 inch and 1 inch. Well, we had y. If we add an inch on both sides, that means that we're going to have this whole thing to be y plus 2. What should the dimensions of the page be, so the entire page, to minimize the paper used? So if we want to minimize the paper has dimensions of x plus 3 times y plus 2. That's this formula right here, and that's the one that we're going to want to minimize. Okay? So now if you're watching this video after trying on your own and after reading in the book and you didn't get it, hopefully this explained it to you and you had an aha moment. If you just are watching the video and you didn't try it on your own, I'm good with that too. Hopefully you went, oh, aha, I'm going to be able to do this on my own. And if you already did this on your own and you're just watching this because you want to hear what I'm going to say, I hope that you are enjoying the way that I am color coding all of this, because I actually think that it looks pretty good. Okay, I digress. Our primary equation. So I like to write primary and secondary. So our primary is area equals x plus 3 times y plus 2. One too many variables. Our secondary, that's funny. Our secondary is going to be, remember what I said in the very beginning. I said, oh, the area of the printing is 24 square inches, and that's x times y. So x times y equals 24. Let's use that secondary equation to get rid of y in the primary equation. So y equals 24 over x. And now you're probably going, oh, I got it. I'm going to press pause because I can do the rest on my own. I'm proud of you. Give it a shot. Maybe some of you have just drowned me out and you're letting the video play and you've muted me. You've just hit mute on your computer and you're not even hearing that I called you out on it. I did. I called you out on it. You hit mute. You're listening to some other song or just watching, and now you're looking at your video and you're going, how come nothing's happening? She's not writing anymore. Did it stop? Did the video stop? Press play, press play. What is she talking about there? Those of you who stuck with me all along, if you didn't mute the volume, I hope you're getting a chuckle. Okay, so now we've got some crazy math to do. I'm going to go right to the derivative. You know why? Because the derivative using the product rule really isn't that difficult. It's a little bit more difficult to FOIL this out and then do the derivative, so I'm just going to do the derivative right now. The derivative of x plus 3 is 1 times the second factor plus the derivative of the second factor, which that's not difficult, that's negative 24 over x squared times the first factor. And that's going to equal 24 over x plus 2 minus 24 over x minus 24 times 3 is 72 over x squared. Well, that's beautiful. 24 over x minus 24 over x. Set that bad boy equal to 0, and we've got some work over here to the side. 72 over x squared equals 2. 2x squared equals 72 means x squared equals 36. X equals plus or minus 6, but do you remember what I said about that minus? That negative 6 is outside of the feasible region because you can't have a negative dimension. So x must be 6. So x being 6 means that from 0 to maybe infinity, right? You've got 6 right here. We want to minimize the area. So I'm just going to confirm. I'm going to put 1 into my derivative. So if I put 1 into my derivative right here, I'm going to get, let's see, 1 is 24 plus 2. 24 plus 2 is, well, let's put it into this one right here because it's less work, right? Because that's still a prime. So 2 minus 72 is negative. 6, let's put a 7 in. If I put a 7 in, 72 over 49, yeah, let's put a 10 in. 72 over 100, that's less than 1, that's going to be a positive. So decreasing to increasing to increasing is going to make this a minimum. So we need x to equal 6 to minimize. And if x equals 6, y equals 4. So our dimensions are 6 inches by 4 inches. I truly hope that you truly enjoyed this video because I truly enjoyed making it.